Logarithmic functions. This is section 7.2 in the book. It's going to introduce something called logarithms. Logarithms are the inverses of exponential functions. So we're going to learn how to switch back and forth between logarithmic function notation and exponential function notation. But here's the definition of a logarithm. Log, there's a little number called b that we call the base of x equals y. This is the logarithmic function. The number b has to be greater than 0, cannot be equal to 1. Alright, x has to be greater than 0. So this number right here has to be greater than 0. Whatever is there has to be greater than 0. This number right here, this is called the base. That's easy to remember because we represent it by a b. This has to be greater than 0 and not equal to 1. Now, so like I said, the logarithm is the inverse of an exponential function. Here is the relationship between the log and the exponential. This, and this. This little number here is the base of the exponential function. The number on the opposite side of the logarithm is the exponent of the exponential. I don't know what to call this one, but I usually just call it the answer. The answer is what this is equal to. The base, the exponents on the other side, and x is whatever the answer is. We have to be able to go from this form into what we call exponential form. I'm going to draw a little box here, put a little box here, and put a little box here. This is the base. Obviously, that's the base. That's the exponent. And this is the answer. Well, the base in this problem is 3. So, we put a 3 in the base. This number is the exponent. So we put the exponent. The x that's left, this is the answer. So this is 3 to the 9th power equals x. Let's say I have log with a base of 7 of 49 equals x. And I want to change this to exponential form. Well, remember, this is the base. So my base is 7. This is the exponent. And the answer is 49. So it kind of makes a little circle. You start here, the base, that's the exponent, that's the answer. Base, exponent, answer. let's see, suppose I had, I don't know, log base b of 15 equals 8. The base is b. The exponent is 8. Where's the 8? Where's the 8? And the answer is 15. So it's going to be important to learn how to do this, because later on what we're going to be doing is solving equations by doing this switching back and forth. Now, we also want to be able to take something in the exponential form and put it into logarithmic form. So, we want to have the word log, we want to have a base, we want to have something here, we want to have something here. This is always the exponent. This is always the base. I guess we'll just put an answer here. The answer. Oops. Alright, let's see. Alright, so in this problem, the base is 3. So here's going to go my base. The exponent is 4. I like that in pink. 4. 4. And the answer turned out to be x. X and x. Let's say I had 3 to the 2x power equals 4. In logarithm form, the base is 3. The exponent is 2x. And the answer is 4, so 4 goes here. So we have to know where the pieces go, so we'll be able to solve these later on. Now, I want to talk about how to evaluate logarithms. Let's say I have this. In order to evaluate logarithms, what you're doing is this number over here, this number is the exponent. So what you're trying to do is figure out what exponent can I attach to 3 that will give me 9. The base is 3, x is my exponent, and it's equal to 9. So, what would the x have to be in this case? Well, in order to get 9, the x would have to be 2 for solving for x. Let's say I had log base 7 of 343 equals x. Now, at base is 7, the exponent is x, and it's 343. So we're trying to figure out what exponent would give me 343, and that is a cube, so x would have to be 3. Let's do log base 3 of 81 equals x. So 3 to what power equals 81? X would have to be 4. 3 times 3 times 3 times 3. Now, suppose I had this. Now, this is a fraction. When we're looking for the exponent and this part is a fraction, X is going to be negative. So anytime the number is in the bottom, my answer will end up being a negative number. So this is what you have to do. You have to change. Well, let me just ask you this. What exponent would I have to use so that I get 8 whenever I raise 2 to that power? So 2 to what power equals 8? Well, the answer is 3. But since the 8's in the denominator, it's going to be a negative 3. If the exponent turns out to be in the denominator, it's a negative exponent. All right, let's say we had log base 5 of 1 over 25. Well, the 25 is in the denominator, so whatever x is, it's going to be negative. Now the question is, negative what? Well, what do I do to 5 to get 25? The exponent would be 2. Suppose I had this. Suppose I put the x here, and I put, I don't know, 64 here, and I put 3 here. Remember, x is the base, that's the exponent, and that's 64. This time we're looking for what x would have to be for me to get 64. So what number do I raise to the third power to equal 64? Well, the answer is 4. So we got different situations. If we're solving for x, if the x is the base, then we're just figuring out what we raise to some exponent. If my number's in the bottom, like the one I just did, my answer will be a negative number. So we have to be able to do this, be able to simplify these logarithms and stuff. Now, there are some special rules for exponents. Logarithms. Special properties, special rules. There are 3 types of logarithms. The first one I'm going to talk about is called the general log. The general logs have different bases. As long as my base is positive and it's not 1, these are called general logarithms. It doesn't matter what goes where, it's just, these are all general logarithms. If this is any number besides 0, if it's a positive number that's not equal to 1, it's called a general logarithm. Now, there are some special rules I want to go over. The first rule is if you have a log with any base and a number 1 here, your answer is automatically 0. Automatically. It does not matter what the base is. Oops. If let's say my base was 879 and I put a 1 right here, the answer is automatically 0. If I have log of base of 1/2 and this is a 1, The answer is automatically 0. If my base is x, and there's a 1 here, guess what? It's automatically 0. If you want some extra credit points, tell me why it's equal to 0. Yeah, as long as there's a 1 in this position, the answer is 0. Alright. Next property. If the base matches, if these two numbers match, the base matches this number, our answer is always 1. These two numbers have to match. So if I had log base 11 of 11, my answer is automatically 1. They match. If I have the log of 2,309, and there's a 2,309 here, oops. $2,309 here, the answer is automatically equal to 1. If I have log of x and there's an x here, guess what? It's automatically equal to 1. So as long as these match each other, your answer will always be 1. Now, there's another property or rule that goes with this, and it's got to do with exponents. Let's say I have this. If these two numbers match, and you've got an exponent, the answer is just the exponent. You can think of it like this. The log and this little b and that big B cancel each other out, and you're left with the exponent. So if I had like log base 7 of 7 to the 9th power, since the 7's match, my answer just turns out to be whatever that number is. Say I had log base 12 of 12 to the 3x power. Well, since these numbers match, the answer is just the 3x. So that's a couple of special properties that we need to know. But that's general logarithms. We have something called common logarithms. Now here's some examples of common logs. Log of 10, log of 1,000, log of 17, log of 1 over 100. Now, I want you to notice something. There's no little number here. Well, so what does that mean? It's got to be a number there somewhere. Okay. Common logs always, let me do this, have a base of 10. So if you see the word log and you don't see a little number right below it, that is a common logarithm. Common logs you can do on your calculator. There is an LOG button on your calculator. Common logs are the only, well, you can do common logs and you can do something else called a natural log. I'll talk about that in just a second. But common logs you can do on the calculator. So if you were to do this on the calculator, you would hit LOG, enter the number 10, and you will get the number, whoops, 1. We'll erase that. If you enter 1,000, oops. Alright, hold on. It just disappeared on me. Go back to that. If you were to take this one and enter, hit log and hit 1,000, you would get 3. If you were to do this one, you'd get I have no idea. If you do this one, you'll get -2. So common logs have a base of 10, and they will not put the 10 there. You're supposed to remember, hey, that's really a 10. I can do those on my calculator. Now, the same properties will apply to the common log as the one I did earlier. If I have this, that's understood to be a 1. Now I can use my calculator to show that, but here's the reason. This is understood to be a 10, right? When these match, my answer is all automatically 1. There's another property. If you had the log of 10 raised to the 9th power, well, it's a common log, so the answer would just be 9. Now this is understood to be a 10, and when they match, and these two match, your answer is whatever the exponent is. So if I had log of 10 to the 9x minus 3 power, the answer turns out to just be 9x minus 3. Since that is a natural log. Since that is a common log. Log of 1. Now, go back to what I said earlier. Regardless of your base, if there's a 1 right here, it is equal to 0. Now, I want to talk about a special type of logarithm. There's a special log that has a base of e, so this will be like an e, and what we call that is a natural log. I mentioned this earlier. E is called a natural base, and it's written as ln, such as this, ln 7. That's read natural log of 7. If I had ln of x, that would be the natural log of x. There is an ln button on your calculator. We can do ln's on the calculator. We can do common logs and we can do ln's. Those are the only types we can do on the calculator right now. Now, I'm going to put some log. I want to just write some stuff over here. Let's say 3 ln 15 ln 37 ln 0.0193. Now I want you to notice, again, there's no little number here. On a natural log, the base is understood to be an e. So I could, if I wanted to, put an e here. Now, it's not necessary to do that, but you may want to do it to help you remember. If there's an ln involved, there's an e involved. E and an e. Now, the problems themselves are not going to have the e in there, but it's your job to remember that's really an e. Common logarithms, you've got to remember that little number is a 10. Every other logarithm will have the base given to you. Now, there are some special properties, just like the other ones, that work for logarithms. I mean, natural logs. If I have this, the natural log of 1, well, what did we say earlier? If this number's a 1, the answer is automatically 0. This property holds true for any logarithm. Doesn't matter if it's common, natural log, or general. If there's a 1 there, it's a 0. Another one is this one. This is a special one. The natural log of e is always equal to 1. And here's why. If we go back to this over here earlier, we had a b here, and we had something here, and we said that was equal to 1 because these two matched. Well, what is the base of a natural log? Well, it is an e. So that means these match, and it's automatically equal to 1. You just won't have the e there. You've got to remember, ln e is always equal to 1. Alright, here's another special property. It goes back, it's the same as that one I just showed you, but it's going to have this. Natural logs and e's are inverses of each other. So what happens is the natural log and the e cancels itself out, and you're left with whatever the exponent is. So it's just like the previous problem where as long as the base is matched, that little number, you're left with just the exponent. So let's say I had natural log of e to the 12x power. My answer is automatically just 12x. The ln and the e cancel themselves out. Let's say I had natural log of e to the 4x squared minus 7x power. Well, guess what? That's just going to turn out to be this. Now, all these properties, it can get a little tricky. You've got to remember all this stuff. Now, they're not hard to remember as long as they follow some patterns, and they're not that bad. While I'm here, I want to talk about the domain of a logarithm. We learned how to find our domains doing fractions and doing roots and things like that. We want to find the domain of a logarithm by doing the same thing as we did for square roots, with one exception. Let's see. It doesn't matter what the base is. I said earlier, whatever's here has to be greater than 0. That's by definition. So this piece, this x plus 4, has to be greater than 0. This is how you find the domain of a logarithm. You will take whatever is in the parentheses, or whatever that is, you set it greater than 0, and you solve for x. And then you put it in that special interval notation. Let's say we had log base 12 of 6x minus 3. Well, I need to put my function notation. So I'm going to take this 6x minus 3, and I'm going to say I want that to be greater than 0. Then I'm just going to solve for x, so move the 3 over, it becomes positive. Divide by 6, so we'll get 3/6, which is 1/2. So we end up with parentheses, parentheses. Now it's got to be greater than 0. It cannot be equal to 0. Alright, so we've got to just practice these rules. The homework is just going over those rules. Just make sure you understand them. There's, I think there's a domain function on there, but just look at the rules and just, it's not supposed to be super hard. In the next couple of sections, we're going to be using these special properties to help us simplify when we start solving equations. Alright, so have fun with this.